Hello friends, welcome to Ex-Amity and Smriti Notes for Biotechnology. In today's lecture, we will study about probability, correlation and linear regression and Bayes' theorem. So let's start with probability and some of the basic terms. Probability is the chance of occurrence of a certain event when expressed quantitatively. Certain terms related to probability are trial, that means an experiment is called as a trial. Outcome, the result of a random experiment is known as outcome. Event, the result, sample space, a set of all possible outcomes from an experiment. Discrete sample space, a sample whose elements are finite or infinite but they are countable. Some more important terms are like exhaustive events, mutually exhaustive events, equally like events, mutually exclusive events, independent events, and dependent events. I have written about each in detail. You can just go through them and have an idea about the basic terms of probability. The probability of an event can be defined as the number of ways it can happen upon the number of possible outcomes. When a coin is tossed, there are two possible outcomes, that is head and a tail. You are not supposed to learn each and every term. You can just go through these terms and have a basic idea about probability and some of its important terms. Now, the important part is probability and its two theorems, that is multiplication theorem and addition theorem. Addition theorem says that if two events are mutually exclusive, that means different, then the probability of occurrence of either A or B is given by their sum of probabilities. I've written the formula as well. For multiplication theory, the probability of event A and B occurring can be found by taking the probability of event A occurring and multiplying it by probability of event B happening. I've given the formula probability for AB. We take probability A into probability of B by A. Next is conditional probability. In the probability of happening of an event A when it is known that B has already happened. Here is the formula of conditional probability of A given that B has already happened. I have given an example also explaining the conditional probability. You can go through it. Next theorem is Bayes' theorem, in which one event affects the probability of the other event, just like the conditional probability. Two important terms used in Bayes' theorem are prior and posterior. Prior means revising a set of old probabilities and posterior means a new or added information, that is, which has been revised. I have drawn a flow chart which shows from prior probabilities to posterior probabilities. Bayes' theorem describes the probability of an event based on conditions that might be related to the event. It is just like conditional probability. And for two events, Bayes' theorem is a method of revising a probability that gives an additional information when obtained. The formula is given below. Next topic is correlation. It basically examines the relationship between two or more variables, and the variables are said to be correlated. There are two important types of correlation. First is positive and negative correlation, and the other one is linear and non-linear correlation. So let's start with positive correlation. Positive correlation means the value of two variables deviate in the same direction. That is, if there is an increase in the value of one variable, then on average, there is also an increase in the value of other variable. Examples where positive correlation are seen is when we measure height, weight, or the income and expenditure. Next is negative correlation. It is vice versa. That means if the value of one variable increases, then the value of the other variable decreases. It is basically seen in correlation between environmental temperature and the bacterial growth. Next is linear That means when value of two variables vary in constant ratio. That means if the value of one variable changes, then the value of the other variable also changes in the same proportion. Whereas in non-linear, change in value of both the variable are not constant in ratio. Example, when we measure the length and weight of the fish. And the coefficient of the correlation, that is small r, measures the degree of association between two values of related variables. If the r takes a positive value, then it is said positively correlated, and if it takes a negative value, it is said negatively correlated. Now, the next topic is linear regression. It is the average relationship between two variables x and y is always fixed. I've written the entire derivation with the formula. In this, numerical is basically supposed to come. In the description box, I'm giving a link in which various numericals are solved using this. You can just go through them and have a look. If you find any difficulty, then do comment and let me know. This is just my notes for you, so that you don't have to go through the links again and again to make the notes. You can just go through these notes and the links given below, so that the concept gets clear. For the next video, do not forget to press the bell button and do like, share and subscribe. Thank you.